I appreciate the time. You are busy. You're still in school?
Yeah, I'm in university at the moment.
I see the neuroscience stuff, but simultaneously the Luria. What's the degree and target kind of education
Sure,
system?
yeah. I mean, it's a mix of things. I'm currently studying computational neural systems as my main direction. It's like a mix of machine learning and actually working in the lab with the brain and with animal models and with the human brain. And then I'm also doing a bit of business, so it's like business economics and management.
Okay, I want to go deep there. You're at
Yeah,
kind of the
let's do it.
intersection of a few different things I find absolutely kind of fascinating, right? So, I mean, obviously, you're kind of doing stuff AI, personalized health, longevity, brain stuff. So I captured some of that. I didn't realize you were actually blending machine learning with that. So, like, brain has kind of the neural net, the neurons and axons, and you're basically figuring out how to mimic that pattern using machine learning.
Yeah, that's very close to what I'm doing. Yeah. So we're looking at the way the human brain works. We want to know exactly the way that the neurons are functioning, how they're talking to each other, and how we can later translate that into the digital world.
Okay. So, oh, man, that has so many questions that it brings up. I've always been like fascinated by brain chemistry and how, like, I mean, I did my undergraduate in argumentation and decision making, and I've always been really fascinated in just like how do you develop like photographic memory, memory palaces, stuff like that. So learning like how neurons and axons work and how you can go, okay, cool. If I read and write and use something and do it handwritten, I can take that little neural net, that pathway, and I can strengthen the connections there so that it's more likely that I remember it. If I go on a vacation, I will sit there and try to take a snapshot by uh, using olfactory senses to go, okay, cool, I need to remember what time, temperature, and smell it is right now so that I can pull up this memory like more accurately, if you will. So
Yeah, smell is a really big part of memory. Yeah, it triggers a lot.
I want to hear more about this because I mean, obviously, you hear about like brain maps and algorithms and stuff like that, and oftentimes I've heard like random forests. They're using decisioning and using algorithms like London Bridge and other things. These are like little decisioning tricks if they can find ways to kind of. And I'm not sure if that's quite the same as mimicking how the brain works, but I do know that like in many cases they're going like I don't know if you have two choices, like what do you do and how do you can do random forest, you can do left, you can do London Bridge, but I would love to hear more about kind of the intersection of how that works with machine learning, because oftentimes machine learning I think of as so much more structured than I do the brain, but the feature weights and the stuff that comes out of machine learning models kind of makes sense. We're just like, all right, cool. Yes, the weights are effectively kind of like the equivalent of the stronger neural net pattern, the stronger kind of axon there, correct?
Yeah, there's a lot of parallels there. I mean, you can take different architectures of neural nets that we have today, and they're quite inspired by the way the natural biological brain works. Like, you can take a look at spike neural networks and connect that to how neurons spike in activity and excitation when there's like electricity pretty much going through them in simple terms. So I'm really fascinated by that thing. I also really like BCIs, so I try to tie in like how we can get people who have tetraplegia, for example, so paralyzed from the neck down, how we can give them certain machinery tools and build machine learning for that to make them be able to walk again or to do something like driving a car with their mind, that sort of thing. That's the type of research I'm really fascinated about, like getting back cognitive function after some sort of trauma or injury, and also being able to give almost like superpowers to people with modern technology in some sense.
I am the guy that would stand in line for that stuff. The I always heard though with like neural links and stuff, it was always really difficult to do because you kind of had to invade the brain and you essentially had like when you make the connection between kind of the hardware and the software, so to speak, the gray matter, you had to give the patient like you had to weaken their immune system so that they didn't like reject it, if that makes sense. And I always heard that
Yeah.
that's why a lot of the past experiments, at least prior to Neuralink, never went well. So just like no, you had to basically like weaken someone's immune system. You just invited things like um, infection and other things. The body ended up rejecting it, and it's your brain. No one wants to sign up for that, right?
Yeah, there are so many issues with invasiveness. I mean, people are working towards making things non-invasive, but it's starting with what you mentioned about the immune system, where you have to like lower the person's immune system's guard in order for there not to be an immune reaction towards like this metal just being put in the brain, um, all the way to the actual electrode that you're sticking in, like degrading very quickly over time and having to be replaced with surgery again. Like there are a lot of risks with doing that, and obviously there could be damage made to the human brain, irreversible damage. So everyone's moving towards technology that's like as non-invasive as possible. So there are like things you can put on the like kind of the surface of the brain. There's things that you can put outside, and they're weaker. There's also a lot of studies going on ultrasound right now, which is like both trying to read signals from the brain and also write to the brain to like induce certain feelings, certain emotions, and intentions to do something.
Huh. How good is it getting? I think the last time I checked in, I saw a guy. I think he was playing like he was using Neuralink to I think play like Call of Duty or Minecraft or something.
That's quite funny. Well, I mean, I guess in the US it's gotten pretty far. There's a lab at Caltech here, which is really, really strong in ultrasound. It's called the Shapiro Lab. He was just recently, I think, asked by OpenAI to like build a more like almost like I think a commercial project or something connected to their machine learning models. So yeah, I mean, there's a lot of potential in the field. I don't think it's available just yet to actually do the things that I'd mentioned, but it's on the roadmap, and I think it's going to be done in the next couple of years. But it's
It,
fascinating.
it's to human trials though, isn't it?
I don't. Oh, with Neuralink or with what?
Neuralink at least.
Yeah. So Neuralink is it's not so much ultrasound. It's like an actual implant.
Yeah, yeah.
So with that, yeah, it's gotten pretty far. I know that there's another company also working on it, Science XYZ. They're doing like retinal BCIs where they're giving people back their vision. So it's not just musculoskeletal stuff. It's also sensory, which I find quite interesting.
Hmm. Why did you get into the kind of space? What brought you to it? That's relatively.
Hmm.
I don't. I mean, it's a little bit obscure. You don't necessarily jump. That's not like the shallow end of the pool, so to speak. You kind of have to be into a few different disciplines simultaneously to get to that one.
I think, like I would say that neuroscience in general is what I'm really really passionate about, and I think I knew I wanted to work with human biology. I knew I wanted to discover like on how some of our thoughts, brains, and things like that work, because I was fascinated by things like you know I was really interested in cognitive performance and resilience and even things like meditation and working on your own thought process from a very early stage. So I wanted to understand how the brain works from the inside, from the outside, objectively, subjectively. And I think I was just really drawn to understanding everything from anatomy to like how the brain looks like, what type of functions does it have in different parts of the brain, and what technology we can use to measure, excitation and things like that. And when the brain feels extremely, when you feel really happy, for example, that has its own neural signature, and I wanted to understand how can we sample that, how can we induce that again, that sort of thing. And then I started just getting experience in labs. I was working in like a fear conditioning memory lab, where I was given almost like 30 or 40 mice, and I ran experiments with them, and it was super cool. I found that one of the most fascinating things, and I started reading up on lots of literature about the human brain and started understanding that the more I learned, the less I actually understand it. So I got even more curious.
Wisdom. What have you found that really works? I mean, this is one of those things you always want to know. I've seen like I don't know. I've followed a bunch of people that will say like, oh, take a inhale a snort of nicotine, and there's all types of like brain hacking. There's a bunch of subreddits associated with that type of stuff. So like, I mean, there's obviously the equivalent of the brain gym, right? Where you know, there's apps that are supposed to be dedicated to like increasing neuroplasticity and things like that. And then I see all this other literature that's just like none of them work. I'm like, I swear I found a couple that felt like they worked. And maybe it was just practice and things like that. Because I mean, I would find a few tricks. I remember one of my bosses just being able to do that thing you see in movies where someone says like a phone number really quickly, and then the brainiac 2 hours later pulls it back from memory. Like, how did he do? I could do that for a while. It was maybe it was just an exercise kind of thing, right? It was like flexing the muscle, and you get good at it just because I would recognize the little tricks, just tiny stuff, little stuff like bucketing the threes and the fours together, and then you'd be able to pull it back in your mind's eye and then memory palace techniques where you'd go and you'd start to assign like weird story narrative kind of stuff to the number
About
sequence.
brain, yeah, about the mind palace. I was super fascinated by the topic. In fact, I was gonna like the first ever startup idea I had was building like a mind palace, and I called it Sherlock because I wanted to make like a virtual reality system where you could go into your memory and physically see and interact with the things that you had, before in your life. And I thought, wow, that would be so cool. But then I decided to pivot into something that I'm more passionate about now. So.
Ow. Okay, wait, play off that because that's a really good idea. I actually use that. I have a kid that has like kind of a bit of a dyslexia, and teaching him how to do a memory palace is how I kind of taught him how to learn and understand vowels.
Mm.
Like OU and other sounds where I'm like, no, 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 like it's an OU. I had him like holding binoculars and stuff like that. And then he would rotate one of the lenses and it would make an OU sound and it would modify how it worked. It worked really, really well.
That's interesting about dyslexia in particular. I interned at a company called Refit, and that was one of my first internships, and they were one of the first companies ever doing something AI related for dyslexia and aphasia in children. So they were actually asking me to build these generative adversarial networks (GANs), which were the foundation to on the path to finding out about how to make LLMs and their creation in
You
general.
have to explain GANs even further now, though, because I don't.
Sure. I mean, the idea is that, well, let me explain the concept that I wanted to start off with. The idea was that you would generate music instead of like you would take text and then generate music on top of it, like song, in order for the students who are using the software to be able to understand the text on a much deeper level. Because students, for example, with aphasia, they can't really understand human speech that well. So they understand it much better if it's sung to them.
You're
So we
like
were
almost an
generating song.
synesthesia type of.
I guess somewhat like that. But synesthesia is like feeling color or like associating numbers with a certain color, whereas this is more not being able to understand human speech on the tone that it's on, but being able to understand song because there's another part of the brain actually responsible for song and for interpreting it and for singing. So I found that awesome. I found that fascinating. It was my kind of one of the first experiences actually working with AI. And then your question on GANs. GANs are quite an interesting like machine learning model. Um, it's one of the first like generative models, I would say, in general. And the way it works is that you have one part of the model, which is trying to come up with examples, trying to, create some sort of, like, let's say, a photograph or music. And then there's another part of the system, which is like a checker. It looks at that and says, well, I know how it's supposed to be in reality. I have a data set that I can compare this to. Does this pass my test or does it not pass my test? And if it doesn't, it sends it back to the creator and tells it, you should improve this because it did not pass my check. Like you were not able to fool me. And this cycle keeps going and going, and both of the models keep training up at the same time, such that the creator becomes better and better at creating, and the discriminator is able to discriminate between what's real and what's not much faster. And then at the end, you get a really, really strong model that's able to generate things to a very high quality because these two parts are like competing against each other. So that's how we worked on it.
I haven't heard GANs in a while. So, because did they? I mean, obviously, it's not a necessarily a precursor, but LLM showed up, and I stopped hearing about GANs. Is it because just GANs were they were good for a very specific use case, and LLMs were just kind of like the equivalent of GANs on steroids and had more breadth and appeal, I guess. Do you know if
I
they
would
still
say
use
GANs
that?
were really popular. They were just not that widespread amongst people who are not actively building like machine learning, classical machine learning solutions. I would say that LLMs became just they overthrew anything done in the machine learning space simply because they became so available and so easy to adopt by everyone. So they just overtook everything, and I would say that's probably the main reason. But GANs are still actively used. I would say they have their own strengths and LLMs have their own weaknesses, so sometimes it's better to use a GAN. But yeah.
Nice. What have you learned in terms of the brain longevity? What is the type of stuff that you do yourself that works, or
Yeah, I
is like,
started this small pet project recently. It actually scaled into something quite fun. I call it Longevity Brain Lab. Basically, I remember I was doing this very comprehensive medical test. I wanted to just understand what is going on with like my medical situation. I want to understand like what's my projection in terms of aging and longevity and that sort of thing. And out of curiosity, I did like a bunch of stuff. And I was talking to the doctor who was interpreting all of these results, and they said, you might want to try something for the brain just out of interest. Incorporate math questions and logic questions into your workouts. I said, what? You mean like strength workouts? And they said, yeah, try that because it's much harder to solve things whilst you're doing strenuous physical activity. And so I got a person to come with me during the workouts, like to the gym, and I would tell them, okay, you literally throw like math problems at me, and I have to do it whilst I'm doing, some sort of warm up or whilst I'm getting weights and using them. It was so much fun. We actually developed a whole technique as to how to increase the difficulty, and after the workout, I would feel just as if both my brain and my body had been working. And the coolest part was that whilst I was solving the problems during these exercises, my the quality of how I completed the physical exercises got better, form got better, subconsciously, completely subconsciously. And I was like, okay, this is a pretty cool result. And we decided to test it out with other people as well, just out of curiosity. And turns out that children, young adults, even seniors, saw some sort of physical improvement um, accompanying these cognitive exercises. We even did this small study, maybe 4 or 5 sessions long, with a person with Parkinson's who constantly had constant tremor in their body. And the moment that they started doing math exercises during this kind of light workout they did, their tremor just stopped. It just stopped during those exercises, even though it's usually continuous during physical exercise. So that was kind of a really interesting thing to us, and it was repeated again and again and again. So now we're planning to publish a study on this, and we'll see where
Wow.
it goes. So this is just like one example. I try crazy stuff like writing with my left hand, trying to write backwards, things that just make your brain go a little crazy. Put it on unusual situations. I don't know, standing on one leg while I was brushing my teeth or something. Um, I like to put it into situations where it's uncomfortable in this kind of like funny, weird way. But I also like to engage in things like learning languages. I am really passionate about that. I've been learning quite a few different languages since I was small, and so just constantly putting it into new dimensions, like languages, music, some sort of mathematical exercise. I feel like that's what keeps it most active, young, and capable.
I like that. They always talk about how like you get new wrinkles in your brain when you're exposed to new stimuli and stuff like that. So like one of the ways where I go like you can't necessarily, well, there's two different ways. You can, sure, you can go to the gym and do things like that that extend your lifespan. Simultaneously, you can't necessarily like time travel, but you can change the perception of time because the exposure to new stimuli actually creates new wrinkles in your brain. It causes new psychological friction, if you will, and time perception slows down, right? People get into rest homes and they talk about how time just passes and they don't really notice time passing. You go outside, go to a festival, go to this stuff. You may not necessarily live longer, but your perception of time will be extended. It'll feel like time slows down. You can actually have in a different way a longer life.
Yeah, I actually read a couple of studies about how, if people were doing like bungee jumping or something, they would have a much more longer perception of time during the moment of the jump because it's such a novel situation. There's so much at stake, and the brain is like, what's going on? So it's really paying attention. It's really present in the moment.
I was mentioning like smelling stuff when I'm trying to remember stuff. My favorite thing is if you go like cliff jumping and stuff like that, you do the smell move in air to memorize what it feels like to be like
Oh
weightless
yeah.
and falling and everything. But you can actually, I can remember going down to Lake Powell in Utah, one of those cool lakes down there, jumping off cliffs and then in the middle of the air go, so you can memorize the sensation of being in midair like that. So that's the
That's so
one that
funny.
actually
I'm gonna do that next time.
it works. It absolutely works. How did this get you pulled into? You work with X Prize.
But yeah. Um, how did I get to work with X Prize? Oh, I'm very
Wait, first
passionate
we should
about.
explain what X Prize is. I've loved X
Sure.
Prize for years. The whole dynamic and economics of it is just fascinating to me. Kind of a lottery system, which I'm sure you know way 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 more than I do. But I remember hearing about X Prize. Obviously, it was when it first came out. It was like 20 years ago. But just the dynamics of lottery incentives, I always thought were really brilliant. And I think Peter came up with that, right? Was that Peter's idea? At least he's the chairman.
Yeah. Yeah, I think he founded the X Prize, and I think it's a super cool initiative because they're funding these like moonshot projects that have the capability of actually, you know, really helping the frontier of humanity move forward. It's the type of stuff that you don't have maybe application in the moment, but it's like 10-year, 15, almost 15-year projects that are funded in order to, accomplish feats that humanity has never even tried or never even thought about before. So they invited me to take part in the prize making committee this year for X Prize, and I got involved in it because I was talking to a lot of the representatives over various conferences in the longevity space, and particularly Jamie Justice. She's always um, talking about the Health Span Prize and how much. And I'm realizing how much X Prize is contributing to the field just because they have this $100 prize specifically geared towards healthcare, which I thought was amazing. Um, so we were talking with her, and she said we involve undergrads from time to time into in X Prize, and you seem like a person who would be able to add value. So they invited me to their annual, I think, meeting in Montreal, and we were talking for 2 days with the team that was there about how to create the novel prizes, how to you know create this like prompt for new teams in a way that's actually going to progress humanity further. And I think I came up with a really crazy idea. I told them, and they did not. At first, everyone was kind of silent when I said it, but I said, let's digitize consciousness. Let's make it possible to transform the human physical brain into something that's digital. And like they fund moonshot projects, but this we didn't even know where to start with it. We were thinking like, what do you have to do? Okay, you have to understand the problem with like you can't actually store more than you can't store the whole brain in any system we have today. Like 1 centimeter cube is like a petabyte of data. Where are you going to get all that sort of storage space
Say a
and capacity to
centimeter cube.
transfer? Yeah,
A centimeter cube of brain matter is a petabyte of data.
a petabyte of data. Yeah. And the only thing we've gotten close to so far, I mean, the Drosophila or the fruit fly brain has been digitized, but it's static. You can't actually see anything change there. You don't see it degrade, learn anything, adapt, react. So it's really hard. And the goal is to be able to digitize a brain in a way where you not only are able to recreate it, but also interact with it and simulate things on it. Like, what if you take a certain pharmacological drug? What if you, I don't know, move to a new location and the environment is completely different around you? Wouldn't you want to understand how that would affect the brain? But it's not only that, it's also the idea of, longevity, escape velocity. And it's a little bit out there, I think, right now. But
What do you mean by longevity escape velocity?
it's a cool concept that people in the space came up with where they're like, you just gotta wait and you just gotta make sure that you stay alive until this longevity escape velocity is kind of
Just
reached
long enough to
long
for
enough until someone comes up with a solution that will keep you,
did we get
eternally
there?
alive.
Have we hit what's the guy at is he at Harvard? That
Sinclair, David Sinclair.
the Sinclair, they're doing the mice trials right now, aren't they? Where they reversed aging in mice, or is it in human? I
Yeah,
don't think
they're very famous for an experiment where they were able to give back vision, restore vision in mice after severing completely like the ocular nerve. So usually, if you cut the nerve, there's nothing you can do. But they
yeah.
managed to add like a cocktail of these different chemicals. They're called the Yamanaka factors. There's 4 factors, and I think they combined 3 of them, and they added it back, and it kind of reverses the cells into more of an embryonic state where they can now differentiate, they can become any other cell. And so they were able to just kind of merge back and give the mouse the ability to see again. So that's what they're famous for that. But longevity escape velocity is something that Peter uses, I would say, quite a lot. Peter from X Prize. He says that it's like this point where there is a solution to just eternal life. And I think that's something that this digitizing consciousness concept is moving towards to some extent as well. I think the first applications would be simulation, but then imagine if you could digitize consciousness, have human kind of brain or memories stored there for a while and then transferred into a new body because cloning is already solved. Um, that would be pretty cool.
How is it? Explain more about the petabyte of data, because I think my brain can maybe hold 10 gigabytes.
Mine too. No, it's
because I get like there's the mapping of it, right? The theoretical, like the MRI. Let's slice it, then compare it. We can kind of see the chemical version of where things go, right?
Yeah.
But
Yeah.
don't we see like the human? How much can the human brain like memorize type of processing? I know it's smaller than a petabyte, right? It's like in the I don't know what it is. Am I talking about the same thing?
It's
I
two
could
different.
completely be
I would
incorrect
say
here.
I would distinguish these two things. It's There's one thing about how much a human brain can remember, and that's I actually don't know the number for that. But the thing that I'm talking about is how much like space it would take to store all of the information within that 1 cubic centimeter. So it's not necessarily exactly the same amount of memory you have, or the
Okay.
function that's described in that cubic centimeter. It's like all the cells, all the connections. It's the velocities of the neurotransmitters. It's the type of neurotransmitters. It's like a whole suite of different stuff. I actually don't know how that was calculated. Unfortunately, I would actually want to find out and look that up. That's the statistics I found out from, because they were trying to
Yeah,
digitize the mouse brain, and I think that was part of the problem. They just couldn't store the information anymore.
I wanted to say I was because I remember reading Ray Kurzweil, I think it was, because he was talking about, and this is a long time ago. So again, this is dated information. But the I think he was saying like we should be able to theoretically upload our consciousness in 2025. And again, this was like 10, 15, could have been 20, 20 years ago, maybe more. Which again, like I go, I think, are we about there?
I think it's a
Still way out.
moonshot project. Yeah, that's why I proposed it. But yeah, I'm curious, like if it's actually going to turn into a prize. It seems like there are people on the funding side interested in this sort of thing. So we'll see
Because
where
it
it
was his,
goes.
I think that was Ray Kurzweil's exit velocity metric. It wasn't
Mm,
necessarily you just have to live long enough to upload your consciousness, right? It wasn't
yeah,
necessarily you need to live
something
long enough
like that.
to reverse aging. You just need to live long enough that we can digitize your consciousness,
Yeah,
which
yeah,
is scary. And there's a bunch of sci-fi movies about that and stuff like that too.
yeah.
But
I know, right? No, it is kind of scary, but at the same time, when you think of, I like the science of it. I'm just curious about how you can solve this. It's an engineering problem, in my opinion. So
I don't know. I'm the last person that's going to be able to answer that question. I'm way too dumb. It's a the premise is super interesting and phenomenal. I've got parents that are getting old right now. And I keep telling them like, hey, hang on there, boss. Because like in terms of again reversing aging and things, I'm going like, hey, you're probably less
right.
than 10 years away. So at the very least, I think what did you think, David Sinclair? I think that's the guy. I think they're moving some of the drug trials, and I've heard about the mice thing, but I think they said that they have some stuff that they're moving into human trials for reversing aging or something, or at least
Hmm.
pausing.
I
You know,
mean, there are so many great labs around the world doing human age reversal, and they're kind of targeting different hallmarks of aging. There's this great paper that came out, the 10 hallmarks of aging, and it was several years ago. I actually met the people who were writing this at a conference when I was. It's a funny story, but I was interning at a drug discovery company, and they became pretty big now. And I did this project on glioblastoma, brain cancer. And I managed to find three novel genetic therapeutic targets that you could use to potentially stop glioblastoma in children. Because there are two types: there's the child one and there's the senior one. And the CEO
remind me
of the
what
company said,
neoblastoma is. What does it do? What's neoblastoma?
glioblastoma is brain cancer. It's like classical brain cancer of glial cells. There
Okay,
are neurons, and then there's glial cells, and they're considered, like helper cells in the brain. And when something, it becomes malignant, there is glioma, which is the benign type of cancer, and then stage 4 glioma is glioblastoma. And usually people have about 12 months to live after they're diagnosed with this. So it's one of the most terrible diseases ever to be. It ruins many, many lives every single year. And it's a disease that nobody wants to touch. Everyone's afraid to touch it because it's so tragic, and because when you start dealing with it, it's like, it's just, it's horrible. But I'm curious about the brain. I like to solve hard problems, so I asked to work specifically on that. And there's potential now to create pharmaceuticals against those genetic targets that I found. But anyway, back to the story. The idea was that the CEO really liked the fact that there was a great case study by a high school student at the time. I think it was 14 when I did that internship. And he said, let's have you present at this aging conference in Copenhagen. Now it's become one of the biggest conferences. It's called ARDD. And all the authors of the 10 Hallmarks of Aging paper were there. And it was just crazy seeing them all in one place. But yeah, and now many labs are working on each of the 10 hallmarks, and I think it's even expanded now to like 20 something hallmarks. So there's a lot of working on there. Interestingly, nevertheless, it's just lifestyle. I think that the most is the most important thing when it comes to actionable results. Um, like I don't know, fasting, for example, for me has been super cool. It's just providing such
Fasting.
brain clarity. Yeah, fasting. So I don't know how it is for others, but when I fast, like intermittent fasting,
Mm-hmm.
your brain just feels so much
Or you get into
more
ketosis,
clear.
right?
Yeah, you get into ketosis. You There are a lot of good processes that happen. Autophagy. You get rid of all the bad cells that are old, unneeded, are just taking up space and energy and resources, and you're just left with the ones that survive because fittest survive when there are no nutrients around. And you just, I don't know, brain wise, I feel like it gives a really clear mind. I like that.
I have the same thing. I think I did a while ago the what do they call it? Cyclical ketosis. My dad mentioned a lot of it too. My dad has Parkinson's, and one of his like treatments or whatever that they gave him involved some kind of fasting stuff. And he would talk again, like it's like your brain gets rid of all the carbohydrates and stuff like that, and all of a sudden you just feel even, right? It's like smooth. There's something that's very, again, smooth. I don't know how else to describe it, but there's a clarity that comes with it, right?
Yeah.
I dig that. The other thing I wanted to ask you about: have you ever started lucid dreaming?
Yeah, I was super interested in that when I was around 12, I think. Um, yeah, around that area. Yeah, I mean, I was even trying to take some courses to understand how it works. And I never really studied the theoretical like framework or like the scientific processes in the brain that occur during that. But I've done a little bit of studying on just classical sleep cycles like REM and deep sleep and what happens then.
Did you ever
But
give
yeah,
it your
why'd you
work?
ask? Once or twice, yeah, and it was very intentional. So it was pretty cool. It was one of the craziest experiences. Yeah.
I had one of my professors in college did his doctorate thesis. I think that's what it was. But he did a lot on lucid dreaming, so he kind of taught us all about it, and he had us watch some movie that was built on the premise. So he had us kind of practice it. So we did a few things like dream journaling, which does work, right? So
Hmm.
like you keep a
Yeah.
notepad next to your bed, make sure that you write things down as soon as you wake up to remember your dreams because they tend to fade if you wait. And so like the second you wake up, if you remember your dream, you write it down immediately, and then you find out when you try to do recall later, it's much easier to pull it back up,
Hmm.
which is part of it. Um, and then for people just listening, the whole premise there is that you wake yourself up during a dream to recognize that you're in a dream, but to stay within the dream. And if you can do that, you can start to control the dream. You can do a bunch of weird stuff. But it's like, hey, well, if you're going to be asleep a third of your life, now you can make use of that other third. You can go, you can teach yourself to fly, visit places that you've never been before, and stuff like that. And it's very cool. I've only had it work twice, but it was ridiculously cool. Like
Right.
I remember when I was walking up the stairs in a house in college, and one of the tricks on this stuff is like they'll do things like flick light switches. There's some things that I guess your brain cannot do during a dream. Can't handle really high frequency light changes. So if you walk around and you almost give yourself like an OCD uh, 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 trait of like flicking light switches as you go in and out of rooms, the lights will flicker. And if you ever flick the lights and they don't flicker, it's one of those tricks to recognize that you're dreaming because your brain can't handle it.
That's interesting. I was trying other stuff. I was trying like using your fingers and moving them whilst falling asleep, as if you're playing on the piano. So that was kind of to get into that transient state. Another one was looking for numbers inside your dream because if they look
Supposedly
weird,
reading is really
yeah,
difficult, right? It'll look scrambled and stuff like that.
or like trying to put a finger through your hand, trying to make it go through, and if you see that it goes through, you're in a dream. So
There you go. And so, yeah, the premise there being just wake yourself up enough. And if you can wake yourself up but stay in the dream, you can then just start to manifest whatever you want. I was walking up. And so, again, a lot of it is like try to just recognize things that shouldn't be. And that's kind of the part of the trick. And I was walking into my house in school, walked up, turned past one of my roommates' rooms, and there was a grizzly bear sitting on his bed. And like sometimes you're in your dream and you're not acting normally. I just remember walking up and walking past his room and looking in and seeing the bear and going, huh, no big deal. And then I walked past and went, wait, I'm definitely dreaming. So I turned around. I made the bear dance with me just to prove that I could, and did some flying and some other stuff like that. And it was awesome. That is one of those things I go, I want to figure out how to do that more. It was a ridiculously cool sensation. One of those things definitely more practice of, right? Um, if you're going to be asleep, you get more fun out of it. And lately, I don't even remember my dreams. I like rarely, like one night a year for probably the last 10 years. I don't even remember them.
Oh
So
my god. I,
maybe
I see so many dreams. It's like a
trade.
show every night. Yeah.
I will trade you. Also, and let's see. And you got in. So you're the company that you built. How far did you get into building it? This is Luria, right? Luria Health.
Yeah, I mean, it's gotten pretty far at this point. We got our first couple of contracts with like mining companies. We're providing services for occupational health.
What is
So,
it? Tell me
risk,
about it. It's like a
yeah,
personal medicine app type of.
no, actually, well, there are several directions we're taking, but the main one is using artificial intelligence for very difficult occupational settings like, mines, where there are a lot of chemicals, gases, machinery. People are under constant risk, and it's a large, like, the company carries large liability for anyone who gets some sort of, injury, or there is an emergency evacuation, a death. The companies are really liable for this sort of thing in the workspace. So we've been developing tools that are able to prevent that in the first place. Risk scoring with artificial intelligence, providing emergency notifications if someone is in a mine and they have, their app that we built for them on their phone, and it's able to catch signals like, is their blood pressure rising, is their pulse rising, and just signal to the nearest medical point that something is wrong. You got to go and help that person get them out of the mine. Because places like that, if the person is not feeling well, anything can happen. They have explosives around. Sometimes bad things happen, and so these companies have a lot of motivation to have everything that can prevent that sort of thing.
Sure.
So we just built a solution for them, deployed it in a company of around 50,000 people, and we're about 30 technical engineers at the moment. It's been lots of fun.
Nice. Congratulations. Um, I worked with. We had one of our clients that built an app. Theirs was kind of for meditation and wellness. But one of the things that I kind of learned about that one, they were tracking uh, vocal fluctuations. You'd count. So instead of like sitting down and doing like typical meditation, you'd literally count out loud to your phone, and it would use kind of the frequency and the vocal, what do you want to call it, but the vibrato and stuff in your voice to recognize frustration. There were like, we would record the audio, turn it into like you turn it into like kind of a CT photo kind of scan type of picture, and then run it over a convolutional neural network to try to see if you could take pictures of those fluctuations. And there were like 96 markers in there. So people were just counting one, two, three, count up to 15, and it would recognize tiredness and lethargy and stuff like that. And one of those things where one of the things you found out is humans are actually horrible at recognizing their own current emotional state. Like you're rude 2 hours before you realize you're being rude because you're hangry type stuff. We're just going like we're just. It seems like we're some of the, in many cases the last. Oh, I feel like garbage. It's like, what did you eat 2 hours ago? It's like, oh, I ate a Boston cream pie by myself, and now I have a. Oh, I like. We're just really bad at putting two and two together in many cases simultaneously. Like little kids, they'll act nuts right before they need to go to bed because they're tired, but they don't realize that they're tired. Someone has to tell them that they're tired, right? So like a lot of the challenge there was just going, oh yeah, you actually found out that a lot of people were actually the last to know, so to speak. Like
Hmm.
heads up, your pulse is rising and all that. You have all of the signals of, having an anxiety attack or whatever. And like, again, you're potentially the last one to realize it, right? Where you find out in marketing, a lot of emotional responses have an exponential effect on people, surprises. So if you can mitigate the surprise, you can mitigate the impact and how significant it is and hits people, so to speak. So
That's
knowing that they're
fascinating.
having a panic attack dramatically lessens the panic of the attack, just because they're like, hey,
Mm.
you know what it is. You're not dying. You're having a panic attack. Oh, okay. Well, at least it's not as severe in that situation. So, um, anyways, neither here nor there. What are the other directions that you're taking on that thing?
Yeah, there are two more. One is like a almost like a doctor co-pilot. We were thinking like, hey, we're already pointing out the people who need help in these industrial settings. Why don't we also help the doctors who might not be, the best doctors, because mining companies or transport companies don't really hire very strong doctors. Why don't we also tell them what to do with the patient when they realize who has a problem and what area of the body is not doing well. Um, so we started building this co-pilot trained on real medical data to not only propose the diagnosis, the precise diagnosis the person has, but also to come up with a really precise treatment dedicated to, considering their whole medical record, considering what problems they came with today, and considering the things that they've been exposed to for the past months or years, etc. So the idea is to create this co-pilot that is able to give a second opinion to doctors um, without replacing a doctor, because obviously a human has to make the decision, but in a way, blocking off anything that wastes their time, like documentation, plus provides insights in terms of this like medical knowledge. It's trained on a lot of patient data, like longitudinal data, where each person we have like 10 to 20 years worth of visits, and
Jeez.
then and also has pretty much all of PubMed, which is the repository, like scientific repository of papers, to understand also the scientific basis, because it's not enough, I think, to know just the medical information, which usually is like treating consequences. We wanted to go into the deep, like the root cause of why things are happening. That's the second direction. That has to go through clinical trials, obviously, but we're preparing for that in the coming months. And the third direction is taking, what we built for doctors and making it accessible to people like yourself and myself. um, I think that everyone should have the best possible medical care and the opportunity to take the right action, but often we are just not informed. So this application is, geared towards fully analyzing your entire medical profile, because everyone wants to know about their medical situation and wants
Sure.
to know what to do with it. So you would upload all of your tests, you could get all your scans in there, and then you would have a personal longevity concierge whose ultimate goal is to keep you alive. And it goes and analyzes all of the stuff that you got. I don't know, wearables, data, labs, even sentimental data, like when you're chatting with it. And then it's able to kind of give you a projector, almost like a digital twin version of yourself, and say, hey, this is what your situation is right now. This is what's going to happen if you take that sort of medication, if you start smoking, things like that. It's like supposed to make some sort of projection, and then it's going to route you to the best possible doctors to take care of you, or lab tests that you have to take, but not generic ones, things that are actually personally picked out for you. I'm very passionate about that direction, but it's a different market, so we're focusing
What's
mostly on the first two at the moment.
what's the decisioning look like on the back of that one? Like, so machine learning with an LLM over the top of it to kind of explain the data. Is it LLM based? Like what type of, people
They
talk about like radiologists and how in danger the radiology profession is.
Mhm.
Um, and a big part of it too is they also see like LLM. A lot of them, like you have to. That's a very specialized kind of use case, right? It's really good because
Mhm.
it has like a lot of the photographic data that it can put into the machine learning side of the equation. But people think they mean like Chat GPT can do it. You're like, no, 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 no. It's
Yeah, I
also
disagree. Like, I don't know. I don't want my records to be analyzed by ChatGPT, because I mean, it's not the problem that it gets to see them. The problem is it's trained on things like Reddit and Twitter
sure.
and things like that. So
Mm-hmm.
I would not trust someone on Reddit giving me medical advice. I don't know
No,
about others,
no,
but
I wholeheartedly agree.
but yeah. So I think
Wholeheartedly
there should
agree.
be a really robust medically trained artificial intelligence system. It's totally possible. We're just working on a solution that's gonna hallucinate less than conventional technology today, or any of the other competing firms out there. There are three phases. The first one is obviously just a proof of concept, like an MVP, to understand that the system actually works. And we built that, yes, on an LLM, just a generic one to test things out. But the next phase is transferring that machine learning system that we built for doctors, which is a classical neural net, um, built in a way that's not going to hallucinate because it's not an LLM, and it's built on the millions of patient records that I mentioned earlier and the medical literature. And we're just going to get that through clinical trials, and then when the infrastructure out there is ready for people to be interacting with a system that's, you know, tech based, that's machine learning based, rather than human, that's when our product is going to be completely ready to launch. And there will be a point where doctors will kind of be required almost to ask some sort of machine or technical system to double check their decision. It's going to come at some point, given how fast technology is evolving today, and we're the company that's going to be ready for when that happens, and when it transitions into their having to be AI in the loop.
Hmm. Interesting. Very cool. Very cool. So you'll have the doctor in your pocket, huh?
Yeah, and then the third phase would be then making it almost like your digital twin, a system that gathers everything throughout years about you and is able to recreate your profile, understand what the tiniest sort of things are going to be able to, are going to happen to you if you take, I don't know, a new supplement, or you try a new food, or you change your diet, or you lose weight. What's going to happen to your biology? That's the goal, to really be able to project that.
Tell me about the training data set. Scope, you're blowing my mind a little bit. So I'm going to make machine learning data sets. So like what would be the target variables that you would be predicting against? And then like
Mhm.
I'm just trying to think, maybe this is too nitty gritty, but I'm just curious about like what is the structure of that data set? Like how do you kind of envision it? What's
Mhm.
in it? What are you predicting? And then how do you interpret that and hand it back to the user, right?
Sure. Yeah, so we have partnerships where um, we basically are able to get data where we see like what is the background that a person came with, like what did they explain is their anamnesis in terms of what, parental diseases, what diseases their ancestors had, what sort of supplements or medication they've been taking for years and things like that. So like, an objective examination as well, so you can see like vital signs, for example. So it's like multiple visits over the course of some sort of time, and in every visit we have the complaints, the medical history, the medications people are taking, the examination, and then the diagnosis that the doctor said, plus the treatment that they suggested. And then the next time, the next data point shows us whether the patient had any improvements, because we can also sometimes get lab tests in these visits, which means that we can see whether the treatment, and first of all, whether the diagnosis was set correctly, because if it changes, that means that it was wrong. And then the treatment that was given did actually help this person. Did the labs get better? Are their complaints different this time? So it's really comprehensive data. Yeah, we transform it into a format where we can input it into the model, and then we train it on very quick. We train it on GPUs on our own servers, because it's medical data, has to be kept very safe. And then we test this with experts, with medical experts and with scientific experts. So we get a data set of anonymized patient records. We like a new one that the model hasn't seen before, and then we ask the model to predict what's the diagnosis, what's the treatment, and then we ask the experts to take a look at the output of the model plus the actual patient data that it got, and then evaluate whether this was correct or not, and how they would change it, for example. And actually, the treatment model, it's going to be able to predict not just the treatment itself, but the dosage that a person has to take, the course for how long this person has to take it as well. So it's really geared towards personalized health.
Um, let's see. I want to go deeper there, but it's still nerdy. It's too nerdy. When you do that, would you not? I mean, like, because the machine learning data set would oftentimes be predicting, oh, this is too nerdy. I need to shut my mouth. But the data set, oftentimes, like the interface, I don't know. In my mind's eye, you have the machine learning data running in the background, and then you put an LLM on top of it to minimize the hallucination, right? Because it has a structured data set that's readily available, so it's not holding too much stuff in memory, but it's able to easily explain it and process it like the vectors and the embeddings that are describing the complaints, so that you can kind of put
Mm.
the system to them, if that makes
We
sense.
didn't. We're not really using an LLM for it, because we want to avoid all the hallucinations. So we're using kind of a classical machine learning. I guess there are several parts, of course. It's not just one model working; it's many.
Mm-hmm.
But there is one model where we, cite medical resources, so that the doctor can see like an explanation as to why the model gave out that specific diagnosis or that treatment. And for that, we have to use an LLM just to,
Yeah. That's what
to
I mean,
find
kind of,
retrieval augmented learning. Yeah.
right? The
Hmm.
medical, I found that the medical professional or the marketer or whoever it is, they have no patience to understand like what kurtosis is and all of those other kind of like other explanations for like feature weights. They don't want to know what a feature weight is. They don't
Hmm.
have the appetite for it. But the LLM can oftentimes explain that result in a way that they will interpret it. So it can remove a lot of the jargon. So it's
Yeah.
there still is the risk of hallucination for sure, right? But it's
Anytime you
minimized.
get an LLM. Yeah.
Yeah, but
Hmm.
like an LLM is always they're good at summarizing, right? It's like, hey, summarize that and remove the jargon. It's like, all right, it could hallucinate, but it's probably minimal and it's unlikely in that situation, right? It's going from point A to point B. The task is very small. It's not like go fill out the prognosis and everything. It's just like no, just summarize the results for that guy. Like okay, cool, yeah, not as risky there. Got it, got it. Awesome, awesome. Um, Andrea, where can people find you? And is the app is I presume it's like a B2B thing and it's for like closed beta for specific companies at this point. It's not something that people can sign up for yet, is it?
Companies can sign up to the solutions I mentioned earlier, like the industrial health one.
Mm-hmm.
They can check it out at luria.health. That's where we have our website. Um, in terms of the app for people like longevity concierge, we have an MVP out as well. That's also accessible via the website. If they want to find me, they should come visit Caltech.
Awesome. Awesome. I appreciate your time. By the way, who do you watch? Who do you follow? Who are your favorite people to kind of pay attention to in the space? Obviously, Peter Diamandis is a nifty one. He's a pretty interesting one. Who else do you kind of like pay attention to? What podcasts and other stuff do you follow?
Hmm. It changes. I would say it changes from month to month because I try to constantly find new information and new resources. So I never kind of really stick. But I would say there are several mentors that I have that I particularly would recommend for people who, are looking for visionaries and people who are shifting the needle. I'd really recommend taking a look at Alex Sharonkov's work. He runs in silico medicine. It's the company I interned at, and kind of this company is the reason I'm in the health space pretty much. Um, yeah, I would definitely go for that. I really like podcasts that are like kind of scientific, but also easily understandable for people with a non-scientific background. I think it's the best when someone is able to translate really rigorous scientific research into something tangible
Sure.
for people.
Like the
So,
Andrew Hubermans
for
and
example, yeah, for example, I would say that, yeah. I actually also found a great podcast recently, I guess for female founders, it might be interesting. Natalie Dawson, she just does great short snippets that I think kind of like put you back on your lane when something goes wrong and you need some sort of like stoic mindset. Yeah.
I like those. I'm a big fan of Stoicism. So awesome. Thank you, Andrea. It's been a pleasure. I appreciate talking to you. Very fun.
Yeah, likewise. Thanks for the opportunity.
Brett, I expect big things, and then people can find you. Yes, Caltech, but you're obviously you're on LinkedIn and stuff too.
Yeah, for sure, absolutely. Yeah, I don't have any like super big public presence, I would say, but LinkedIn is probably the best place. If students are interested in getting involved, I run a club at the university called the Celtic Longevity Club. It's open to people who are interested in getting into the space. So,
I love it. Thank you. We'll talk to you again soon.
thanks so much. Bye.